Okay, starting workbench. Opening the project. And checking the inventory report for which programs have been loaded. That's the top level report with a summary. Each of the individual reports are as follows. That's a list of the assembler modules, the macros, items that are called but are not in the project, files allocated to the project, and the assembler listings that have been imported, and the summary again. Other reports that are available: function catalog details, which are the details of each module, number of lines, complexity, calls to and from. We'll see in graphical form in the function catalog later. External module details, which shows all those modules called from the project but are not within the project. The workbench also analyzes code to look for dead code, and this dead code details report lists those modules which we believe have dead code. And there is also an audit report, which is an overview of the project. As you can see, the number of modules, the lines, the executable lines, the complexity, in summary and in detail, the modules with the lines in the source code and the lines from the listing, and complexity, etc. And it goes down further to show all the linkage details, what's called by what. Well, those are the reports. Okay, now we're going to look at some of the interactive tools, starting with the function catalog. The function catalog is an overview of all the components in the project, broken down here as modules, macros and copybooks. This is a tree structure on the left which allows you to open up each heading. So you can see the modules. If we select module on the left hand tree, you get the details in the right hand view pane, which gives you a little more detail. All the modules, again, number of lines, complexity, and the McCabe, which is an industry standard complexity. These columns are sortable, so you can see which is the most complex or has the most lines, or the standard alphabetic. There's also a tab here for calls, which doesn't show a great deal with modules selected, but if you select a particular module, it will then show you what calls it and what it calls. And as this module has no subfunctions, this is empty. I'll fold the detail pane away as we don't really need that for navigating the project. The next tool we're going to look at is the function call graph. And here you can select which functions you want to graph. As a first step, you generally select everything in the project. And this shows which modules call which. You can filter the type of functions that appear in this. At the moment we're only showing program modules. You could include user macros and system macros, for instance, and you get a much bigger map then. You can use Control F to fit everything on the screen so you get an overview of it. Using the zoom tool here at the top, you can rubber band a point of interest and it zooms into that, so you can see what, in this case, some of the more called macros are. These are red with an X at the front because they're not part of the project. Next, we will look at the program editor. To select which program to edit, if you double click on the module in the function catalog, it makes it the current module for the workbench. So we'll go with the one we first chose. This then enables the text editor icon in this case. The editor does most things you would expect from an assembler aware editor. For instance, we can mark a line if we want to come back to it. As this is a multi-user tool, by default the editor opens in read-only mode, so that's just a little warning. We can also mark blocks of code if we want to. And these colours can be specified. As I said, the editor is assembler aware, and one of the things it's aware of is the dead code, which we saw in the report earlier on, and it's marked all the dead code blocks here in a nice sandy colour. You can see it's dead code because there's an unconditional branch here before we get to the code, and the code's not labelled or referenced from anywhere. Probably a few more bits of dead code down here. The cyan markings are where the macro has been expanded from the source. The editor obviously has many more functions than that. Just as a brief idea, you can see some of the key shortcuts here for locating data items, jumping to the next executable line, all the different types of marking of line and navigation as you'd expect, to file into file, all that sort of thing. Another view you can have of a module is the program flowchart. Like the other graphical options, you can use Control F to fit it all in a screen, and the plus minus buttons to zoom into a particular piece or zoom out, and again the same zoom function, so you can rubber band it and it will zoom in. This tool will work in conjunction with the editor, so that you can select something in the flowchart and see it in the editor. And now we've opened the editor, you can see some of the coloured markings that have been brought across from the editor. For instance, this piece of dead code is all coloured the same way as in the editor, and you can ask it to show the line in the editor and it will move across and do just that. And of course we can do it the other way round as well. If we mark a block of lines, for instance, and show the line in the flowchart, it relocates the flowchart and you can see the highlighted block there. And of course you can zoom it down to get some context or zoom in to see the detail. Right, so I'll just tidy these away. Now we'll look at the way Workbench can improve the process of change analysis and also estimation of the effort involved in a chain. To do that, we will use a tool that we call the Batch Data Tracker. This allows us to identify pieces of data within the project so we can see where changes will be required. So you can search either for a data item whose name you know that you need to change. In this case, we know we have some called end date, and we include that in our list because we can build up a list of things that the data tracker will search for. We can also search for a string in a comment next to a data item and then identify those data items. So we'll search for password in this case. Having built up our list of search terms, we then press the apply seek table, which then looks through the database of data items on the left here. If we change the display from all fields to matched fields, you can see which data items it's identified as being involved in this password date change. And you can of course go down and change the identity of any of these to make them either included or excluded. And once we're happy that we've got a sensible set of data items that will be affected by the change, we can then export the results back into the workbench. We go back to Batch Data Tracker, and perform the global scan. This then takes the search terms that the data tracker has found and looks through the project to find those modules and highlights the lines in question. This does produce a report of those items it's found, again using Access as the database here. This is the front page of that report, the summary, which tells you there are 144 hits, and 16 modules. And we can look at the individual reports here. The module summary by name of those modules where a match has been found. And that's the same list, but it's telling you how many hits in each module, so you can see which module has more work required for the change. And in detail there it tells you the name and the particular search term that has caused the hit. So if we look at one of those modules and open it in the editor, you can see that the system has highlighted those lines where that particular data item is referenced. And of course, if we open the program flowchart, you can see them highlighted there as well. Another way the workbench can help identify the scope of any change is code slicing. That's where you identify a data item and then the tool shows which statements could affect the value of that data item and therefore would need to be considered for a change. So if we open the editor for the DSA user module and pick a data item, I think we'll have this one, and we select that and say code slice on this data item. So create annotated files. In this case we'll just look at the data flow and backwards to that point in the program and ask it to annotate the code, which it does reasonably quickly. We then open up the flowchart and the editor again. You can see in the editor this is the data item we chose, and it's highlighted it in lilac for us. And there are a couple of steps earlier on where statements that could affect that data item can be found. And we can show the line in the flowchart. And we can see the steps previous. Where based on these decisions a different value will be set. Obviously we can make the flowchart smaller so you can see it in better scope. You can see these decisions run down to the point where we're looking at that data item. Rather than just looking at the data that could get changed, we can also examine a code slice for both the control flow and the data flow for a particular item. So if we go back and try that again, this time selecting both control and data, select the code slice criteria again, go back to create annotated files, and this time we'll still restrict it to backwards so we have a little bit of clarity, and go for both data and control. Then open up our two views of the module. And you can see a much more extensive list of statements that could affect the value of that if we also take into account the control flow. And likewise on the flowchart, you can see there are a number of steps that have gone lilac, a lot of them decision boxes. And of course we can walk backwards and forwards between the flowchart and the editor to examine them in more detail.